NEC Section 370.23F states that conduit fittings shall be approved for the purpose and shall be used only with the type or types of raceway or cable for which they are intended. Galvanized rigid conduit (GRC) nipples are approved for use with rigid conduit. Flat round box covers are not threaded hubs specifically designed for conduit termination. An inspector's reasoning for rejecting the installation is likely based on the fact that a flat round box cover is not a threaded hub approved for use with conduit. To comply with NEC 370.23F, consider using one of the following options. Firstly, use a threaded hub. Replace the flat round box cover with a threaded hub designed for conduit termination. Secondly, use a conduit body with a threaded hub. Install a conduit body with the threaded hub directly into the concrete pour. The GRC nipple can then be terminated into the hub and the conduit body. Additional considerations include ensuring that the threaded hub's thread size matches the GRC nipple. Use lock nuts to secure the nipple to the threaded hub. Protect the nipple from damage with a plastic bushing or similar device. If the weight of the fixture exceeds 25 pounds, additional support may be required. While the GRC nipple and flat round box cover combination may seem practical, it does not meet the requirements of NEC 370.23F. To ensure compliance and pass the electrical inspection, it is necessary to use approved fittings designed for conduit termination. When working with electrical systems, it is crucial to adhere to the National Electrical Code, or NEC, to ensure safety and compliance. Conduit systems, in particular, require careful attention to detail, especially regarding the proper use of fittings. One common point of confusion arises when using galvanized rigid conduit, or GRC, nipples in conjunction with flat, round box covers. The NEC provides specific guidelines on the types of fittings that are approved for use with different raceways and cables. Section 370.23F explicitly states that conduit fittings must be approved for the intended purpose and used only with the type of raceway or cable for which they are designed. GRC nipples are designed and approved for use with rigid conduit systems. These nipples provide a short length of threaded conduit that allows for connections between enclosures, boxes, or other conduit runs. Flat round box covers, on the other hand, are typically not considered threaded hubs specifically designed for conduit termination. They are generally intended to cover electrical boxes and provide access to wiring connections. An electrical inspector might reject an installation using a GRC nipple and a flat round box cover due to the fact that the box cover is not an approved fitting for terminating conduit. The concern is that the connection may not be mechanically sound or provide adequate grounding continuity, potentially leading to safety hazards. To comply with NEC 370.23F and ensure a safe and compliant installation, there are several alternative solutions to consider. One option is to replace the flat round box cover with a threaded hub specifically designed for conduit termination. Threaded hubs are available in various sizes to match the diameter of the GRC nipple and provide a secure and approved connection point. When selecting a threaded hub, it is essential to ensure that the thread size matches the GRC nipple to create a tight and reliable connection. Lock nuts should also be used to secure the nipple to the threaded hub, further enhancing the mechanical strength of the connection. Another viable solution is to install a conduit body with a threaded hub directly into the concrete pour. A conduit body, also known as a conduit, is a fitting that provides access to the interior of a conduit run for pulling wires, making splices, or changing direction. Conduit bodies are available with threaded hubs that allow for direct connection to GRC nipples. By embedding a conduit body with a threaded hub into the concrete, you create an approved termination point for the GRC nipple. This method provides a secure and compliant connection while also offering the flexibility to access the wiring system in the future. When installing a GRC nipple, it is also important to protect the nipple from damage. A plastic bushing or similar device can be used to cover the end of the nipple, preventing sharp edges from damaging the wires or cables passing through it. This simple step can help prolong the life of the wiring system and prevent potential electrical hazards. In addition to these considerations, it is essential to ensure that the weight of the fixture is adequately supported. If the fixture weighs more than 25 pounds, additional support may be required to prevent strain on the conduit system. This support can be provided by using straps, clamps, or other approved methods to secure the fixture to the building structure. The NEC provides specific guidelines on the types of support required for different types of fixtures and conduit systems, so it is important to consult the code for detailed information. In conclusion, while using a GRC nipple and flat round box cover combination may seem like a practical solution, it does not meet the requirements of NEC 370.23F. To ensure compliance and pass the electrical inspection, it is necessary to use approved fittings designed for conduit termination. By using threaded hubs or conduit bodies with threaded hubs, you can create a safe and compliant conduit system that meets the requirements of the NEC. Always remember to consult the latest edition of the NEC and local electrical codes for specific requirements and guidelines in your area. Electrical codes and standards are constantly evolving to address new technologies and safety concerns. Staying up to date with these changes is crucial for electrical professionals and anyone involved in electrical work. The NEC is a comprehensive document that covers a wide range of electrical topics, including wiring methods, equipment installation, and safety requirements. It is developed and maintained by the National Fire Protection Association, or NFPA, and is updated every 3 years. To stay informed about the latest changes to the NEC, consider subscribing to industry publications, attending training courses, and participating in professional organizations. These resources can provide valuable insights into the code and help you stay ahead of the curve. In addition to the NEC, local electrical codes may also apply to your project. These codes are often based on the NEC but may include additional requirements or modifications specific to your jurisdiction. It is important to consult with your local electrical inspector to determine which codes apply to your project and ensure that your installation complies with all applicable regulations. When working with electrical systems, safety should always be your top priority. Electricity can be dangerous, and even a small mistake can have serious consequences. To protect yourself and others from electrical hazards, follow these safety tips. Firstly, always to energize the circuit before working on any electrical equipment. Use a voltage tester to verify that the circuit is de-energized before touching any wires or components. Secondly, wear appropriate personal protective equipment, or PPE, such as safety glasses, gloves, and insulated shoes. PPE can help protect you from electric shock, burns, and other injuries. Thirdly, use tools that are properly insulated and in good working condition. Inspect your tools regularly for damage and replace them if necessary. Fourthly, never work on electrical systems in wet or damp conditions. Water is a conductor of electricity, and working in wet conditions can increase the risk of electric shock. Fifthly, if you are not comfortable working on electrical systems, hire a qualified electrician to do the work for you. Electrical work should only be performed by trained professionals who have the knowledge and experience to do the job safely. By following these safety tips, you can minimize the risk of electrical hazards and ensure a safe working environment. Remember, electricity is a powerful force that should be treated with respect. Always take the necessary precautions to protect yourself and others from harm. In addition to the technical aspects of electrical installations, it is also important to consider the aesthetic appearance of the finished product. A well-designed electrical installation can enhance the overall look and feel of a space, while a poorly designed installation can detract from its appearance. When designing an electrical installation, consider the following factors. Firstly, the placement of electrical outlets and switches. Locate outlets and switches in convenient locations that are easily accessible and do not interfere with furniture or other fixtures. Secondly, the type of lighting fixtures used. Choose lighting fixtures that complement the style of the space and provide adequate illumination. Thirdly, the routing of wires and cables. Conceal wires and cables whenever possible to create a clean and uncluttered look. Fourthly, the color and finish of electrical components. Choose electrical components that blend in with the surrounding decor. By paying attention to these details, you can create an electrical installation that is both functional and visually appealing. A well-designed electrical installation can add value to your property and enhance the overall quality of life. When planning an electrical project, it is always a good idea to consult with a qualified electrician. An electrician can provide valuable advice and guidance on all aspects of the project, from design to installation. An electrician can also help you select the right materials and equipment for the job and ensure that the installation complies with all applicable codes and regulations. Hiring a qualified electrician can save you time, money, and stress in the long run. An electrician can also help you avoid costly mistakes and ensure that the project is completed safely and efficiently. In addition to their technical expertise, electricians also have a thorough understanding of the NEC and local electrical codes. They can help you navigate the complex world of electrical regulations and ensure that your installation meets all requirements. When choosing an electrician, it is important to select someone who is licensed, insured, and experienced. A licensed electrician has met the requirements for education, training, and experience set by the state or local licensing board. Insurance protects you from liability in case of accidents or damage that may occur during the project. Experience is important because it indicates that the electrician has a proven track record of successful projects. To find a qualified electrician in your area, ask for referrals from friends, family, or neighbors. You can also check online directories or contact your local electrical contractors association. When you have a few potential candidates, interview them and ask for references. Check the references to verify the electrician's qualifications and experience. Once you have chosen an electrician, get a written estimate for the project before work begins. The estimate should include a detailed breakdown of the costs for labor, materials, and any other expenses. Make sure that the estimate is clear and easy to understand and that it includes a guarantee of the work. By following these tips, you can find a qualified electrician who can help you plan and complete your electrical project safely and efficiently. A well-planned and executed electrical project can add value to your property and enhance the quality of life. Always remember to prioritize safety and compliance with all applicable codes and regulations. Electrical work should only be performed by trained professionals who have the knowledge and experience to do the job safely. When working with electrical systems in parking garages, it is important to consider the specific environmental conditions that may be present. Parking garages are often exposed to moisture, chemicals, and extreme temperatures, which can affect the performance and longevity of electrical equipment. To protect electrical equipment in parking garages, use enclosures and fittings that are rated for the environment. These enclosures are designed to withstand moisture, chemicals, and other harsh conditions. It is also important to use wiring and cabling that is rated for the environment. These cables are designed to resist abrasion, corrosion, and other types of damage. In addition to these precautions, it is important to inspect electrical equipment in parking garages regularly for signs of damage or wear. Replace any damaged equipment immediately to prevent electrical hazards. Parking garages are often dimly lit, so it is important to provide adequate lighting to ensure safety. Use energy-efficient lighting fixtures to reduce energy consumption and save money. It is also important to provide emergency lighting in case of a power outage. Emergency lighting can help people evacuate the parking garage safely. When working with electrical systems in parking garages, follow all applicable codes and regulations. These codes are designed to ensure the safety of people and property. Electrical work should only be performed by trained professionals who have the knowledge and experience to do the job safely. By taking these precautions, you can ensure that the electrical systems in your parking garage are safe, reliable, and energy efficient. A well-maintained electrical system can help protect your property and the people who use it. Remember to consult with a qualified electrician for all your electrical needs. In the specific scenario of wiring a parking garage with embedded boxes and 3/4-inch threaded hubs on the fixtures, the choice of fittings is crucial. The rejection by the electrical inspector highlights the importance of using approved components. The initial installation, using a 4-inch by 3/4-inch GRC nipple through a flat round box cover with lock nuts and a plastic bushing, was deemed non-compliant. The inspector cited NEC Section 370.23F, which emphasizes the use of fittings approved for their intended purpose and the specific raceway or cable type. The key issue is that a flat round box cover is not a threaded hub designed for conduit termination. It lacks the necessary mechanical strength and grounding continuity required for a safe and code-compliant installation. To rectify this, two primary solutions present themselves. Firstly, replacing the flat round box cover with a listed threaded hub. This hub should be specifically designed for conduit termination and compatible with the 3/4-inch GRC nipple. The hub provides a secure and mechanically sound connection point. Secondly, installing a conduit body with a threaded hub directly into the concrete pour. The GRC nipple can then be terminated into this hub. The conduit body allows for access to the wiring and provides a compliant termination point. In either case, several additional considerations are crucial. Firstly, ensure that the threaded hub's thread size precisely matches the GRC nipple's thread size. This ensures a tight and secure connection. Secondly, use lock nuts to firmly secure the nipple to the threaded hub. The lock nuts provide additional mechanical strength and prevent loosening over time. Thirdly, protect the nipple's end with a plastic bushing or similar device. This prevents damage to the wires as they enter the conduit system. Finally, and importantly, if the fixture's weight exceeds 25 pounds, additional support will be required beyond just the conduit connection. This might involve additional bracing or support structures to bear the weight and prevent strain on the electrical connections. The overarching principle is that all components used in an electrical installation must be listed and approved for their specific application. Using non-approved components can lead to safety hazards, code violations, and potential equipment failure. In the case of conduit systems, proper termination is paramount. The connection must be mechanically strong, provide reliable grounding continuity, and protect the wiring from damage. While a GRC nipple and flat round box cover combination might seem convenient, it falls short of meeting these requirements and violates NEC 370.23F. Adhering to the NEC is non-negotiable in electrical work. It is not just a matter of following rules but ensuring the safety of people and property. The NEC is developed by experts and based on years of experience and research. It addresses a wide range of electrical hazards and provides guidelines for minimizing those risks. Ignoring the NEC can have serious consequences, including electrical fires, shocks, and even fatalities. Always consult the latest edition of the NEC and local electrical codes to ensure that your electrical installations are safe and compliant. Remember that electrical codes are constantly evolving to reflect new technologies and safety concerns. Staying up to date with these changes is essential for all electrical professionals and anyone involved in electrical work.